students, Assalamu alaikum. Welcome to our virtual chemistry class. This is Mohammad Asif Iqbal, Senior Teacher, Department of Chemistry, Milestone College. In this class, I am going to discuss with you some of the very important topics taken from chapter 3, which is structure of matter. Before go through the lesson, there are some advice that all you should bear in mind. You are supposed to attend this class inside the classroom, but due to pandemic, you are attending this class in online. So you must watch this class with utmost sincerity from beginning to end and keep yourself and your family safe from COVID-19. Dear students, in the previous grade, you already introduced with matter, but in this class I'm going to discuss more elaborately about matter. We know matter can be divided into two different groups, element and compound. I'm write down number 1 element and number 2 compound. So, what is actually an element? What is element? You can see element the matter which does not yield anything, the matter which does not yield anything but itself when divided is called an element. So, in the first time, element, we got the definition, the matter which does not yield anything but itself when divided is called an element. Now, the total number of invented element in this world is 118, and among them 98 elements are found in the nature and rest others are made artificially inside the laboratory. So total number of element 98 elements are found in nature. So we know that everything which is our surroundings are composed with different types of elements. Even human body also composed with different types of elements, and the total number of elements present in human body is 26. Dear students, you can see human body contain 26 elements. So you get 2 of the MCQ question and answer, which is how many elements are found in nature, which is 98, and human body contain 26 elements. Now come to the second one, which is compound. Now I'm going to write down the definition of compound. What actually compounds is the matter which, if divided give away two or more different types of elements are called compound. Now students, you can see the matter which if divided give away two or more different types of elements are called compound. So we can find that compound is composed with different types of matter. For example, water, carbon dioxide, etc. In these two examples, we can find out that water is composed with two hydrogen atom and one oxygen atom. On the other hand, carbon dioxide is composed with one carbon atom and two oxygen atom. So, in every cases, we can find that every compound is composed with different elements and the ratio of that elements remain the same. How actually every matter composed with? Matters are composed with very small particles, and these particles can divide into two different groups, atoms and molecules. Now you can see number one, atom, number two, molecule. Now students, come to the point what actually atoms are. Now you can see in the board, you must write down in your own copy atoms are the smallest particles of the elements. Atoms are the smallest particles of the elements that contain the characteristics of the elements. Now you can see atoms are the smallest particle of the elements that contain the characteristics of the elements. Now student, come to the second one, which is molecule. What actually molecules are? Now I'm going to write down the formula of molecules. You can see what actually molecules are. When two or more atoms remain connected with each other in chemical bond, then it is called molecule. Now you can see when two or more atoms remain connected with each other in chemical bond, then it is called molecule. Now students, molecules are two types. elements molecule and compounds molecule. I'm going to give you some example of elements molecule and compounds molecule. For example, you can see oxygen O2, carbon dioxide, oxygen O2, hydrogen H2. Both of these are the molecules of element, and carbon dioxide, water. Both of these two molecules are compounds molecule. So another very important thing which you should bear in mind, atom cannot exist freely in the nature except inert gases. I repeat once again, atoms cannot exist in the nature, but molecule can exist in the chemical reaction. These elements are written in small form. This small form is known as symbol. So what actually symbols is the abbreviated form of English or Latin name of an element is called its symbol. Each element has its own symbol. So I have write down the definition of symbol, and I'm going to give you an example of some symbols. You can see chlorine atoms. The symbol of the chlorine is Cl. Cobalt element, the symbol is Co, and carbon, which is C. So these are some of the examples of symbol, and I'm going to discuss how this symbol is write down. Students, there are some rules to write down the symbols of the element. I'm going to discuss with you how to write down the symbol of different elements. These are the rules. The first rule, the first letter of an English name of an element is usually the symbol, and that has to be written using capital letters. I repeat once again, the first letter of an English name of an element is usually the symbol, and that has to be written using the capital letter. For example, you can see hydrogen is the English name of a gas, and the symbol is H. Another one is oxygen, which is an English name of another gas, and the symbol of that gas is O. Similarly, nitrogen, and the symbol of this is N. So this is the first rule which maintain to write down the symbol of the element. Now come to the second one. If anything happened like that, two English name has same first letter, then what will happen? When the two first letter of two or more elements is the same, one of them is expressed by the first letter, the other elements get the first two letters. The first letter is capitalized, followed by the small hand second letter. I repeat once again, listen very carefully. When the first letter of two or more elements is the same, then one of them is expressed by the first letter, then what will happen to the others? The other elements get the first two letters. The first letter is capitalized, followed by small hand second letter. I'm going to write down some of the example. You can see. We know the symbol of carbon is only C, but when we write down cobalt, the symbol will be C, small letter O. Or chlorine, the symbol will be Cl. Now you can see three of the elements provided here: carbon, cobalt and chlorine. In these three cases, first letter is C. But when we are going to write down the symbol, what we'll do? In first case, we'll take the first letter and other case we will take two letters, but first letter must be capital word and second letter must be small word. There are also some elements who got their name from their Latin name. So you can see some elements have got their symbols from their Latin name. For example, sodium, the Latin name of sodium is natrium and the symbol is Na, which is actually taken from Latin name, not from English name. A similar way, silver, the Latin name of silver is argentum, which is Ag. The Latin name of tungsten, tungsten is wolfram, which is W. When we write down the symbol, we will write down the W. Similar way, mercury, which is hydrogram, which is written down Ag. So these are some of the way how can we write down the symbol of different types of elements. Students, we denote elements atom by symbol, but how we denote the molecules? So we denote the molecules by writing the formula. Now what is the formula? We can see a chemical formula that gives the total number of atoms of each element in each molecule of a substance. I repeat once again, listen very carefully. It's a very important definition. What is actually formula? A chemical formula that gives the total number of atoms of each element in each molecule of a substance. Now students, we know there are two types of molecule, elements molecule and compounds molecule, and I'm going to write down some of the formula of molecules. You can see when we write down the formula of oxygen, it will be O2, hydrogen, H2, and when we write down the formula of water, that will be H2O, which is the formula of a compound. Similar way, carbon dioxide, which is the formula of a compound. So these are the formula of different molecules. Here oxygen and hydrogen is the formula of elements molecule, and water and carbon dioxide is the formula of compounds molecule. Actually there are different types of particles remain inside the atom. So which particles are? You can see the particles inside the atom: electron, proton and neutron. Every atom except hydrogen are consist of three different particles. These particles are known as permanent particles, where electron is revolving around the nucleus, and at the center of the atom there are two particles remain, which is proton and neutron. So now come to the first one, electron. Electron is the smallest, lightest particle. Electron is the smallest and lightest particle of the element. The charge of an electron is actually negative in charge. Electron is actually negative in charge. The charge of an electron minus 1.60 into 10 to the power minus 19 coulomb, which is considered as relative charge is 1. The mass of an electron is very small, and the mass is 9.11 into 10 to the power minus 28 gram. So this is one of the lightest particle remain inside the atom, and the mass of electron is 1 by 1804 times of the mass of proton. So it is very much light particle inside the atom. Now come to the second one, proton. Proton is also a permanent particle inside the atom, and the charge of this proton is considered plus 1.60 into 10 to the power minus 19 coulombs. So which is equal to the charge of electron, but the charge of electron is considered minus, where the charge of proton is opposite to the electron, which is plus 1.60 into 10 to the power minus 9 coulomb. Now what is the mass of the proton? We can see the mass of a proton 1.67 into 10 to the power minus 24 gram, and the relative atomic charge, the relative mass will be 1, and the relative charge of proton also considered plus 1, where the relative charge of electron is considered minus 1. So we can find out the two permanent particle of atoms, where we get electron and proton, where the charge of electron is minus 1.60 into 10 to minus 19 coulomb, which is considered as minus 1, and the mass is very low, which is 9.11 into 10 to the minus 28 gram. So it is considered almost zero mass while we consider the total mass of the atoms. On the other hand, the charge of proton is 1.60 into 10 to the minus 19 coulomb, which is considered plus 1, and the mass is 1.67 into 10 to the power minus 24 gram, which is considered 1 as relative mass. Now the last one, which is neutron. Neutron does not possess any charge. It is not positive or negative charge. It is completely neutral. It is also one of the most important permanent particle which is visible every element except hydrogen atoms. Now what is the mass of neutron? The mass of neutron is 1.675 into 10 to the power minus 24 gram. It's very few larger than the mass of proton. You can see the relative mass is considered is also 1. So these are the permanent particles which are visible in every atoms of different elements. Now students, I am going to discuss with you some of the important features of atoms by which you can distinguish atoms from one to another. The first important thing is atomic number. So what actually atomic number? The atomic number is the total number of proton present in an atom. So you can see the definition here. Atomic number of an element is determined by the number of proton present in a nucleus of the element's atom. So the total number of proton present in the atoms of an element is known as atomic number. For example, I'm going to write down an example. For example, sodium has the atomic number of 11. The atomic number of sodium is 11, which is very special for sodium. Only sodium has the atomic number 11. Now come to the next one, mass number or nuclear number. Mass number or nuclear number. The total number of protons and neutrons, both protons and neutrons present in an atom is called mass number or nuclear number. So from this definition we can say that the total number of proton and neutron which is present in a particular atom is known as its mass number. For example, I am going to write down an example. Sodium. The mass number of sodium is 23. The mass number of sodium is 23. From the atomic number and mass number, we also get the number of neutrons present in an atom. In case of sodium, we can find out the neutron number of sodium. Neutron number 23 minus 11, which is 12. So the neutron number of sodium is 12. So from atomic number and mass number we will find out that how many protons, neutrons and electrons are present in an atom. I repeat once again, from atomic number and mass number, we will be able to find out the proton number and neutron number. Now students, you can see a symbol which I write down as an X, which can be any atom, and at the top right corner, left corner, at the top left corner you can see A. Here we write down the mass number of that element, and the bottom left side we can write down the Z, which is the atomic number or the number of proton present in that atom, and the C is the charge number, and last but not least N is mentioned to denote how many atoms are present there. So this is all about the symbol of an element. Dear students, hope that you understood all the topics discussed in this class. If you have any problem, if you have any inquiry, please ask question to your respective chemistry teacher, and hope see you soon. Thank you for being present from beginning to